in Stanford. So he spent many years to collect such a big database and use that database to host a contest. The contest is let every researcher, every every student to use the database and their models to see whether they can identify the class in that data set. So it is very, very helpful for the study, for the research of artificial intelligence. And the last one is the open source, the concept of open source, software tools, and community. So GitHub, maybe you already know GitHub. GitHub is a big collection of free program, free code you write, you can share to others. And another community is called Kaggle. Kaggle is a community that you can share your models to everyone, and others can improve that model and feedback to Kaggle. And Kaggle, another important goal is to have contest of data science. So many data owner can donate their data to Kaggle and host a contest. So everyone can familiar with different category of data and use their knowledge to create AI models. So these are two famous open source community. So GitHub was acquired by Microsoft and Kaggle was acquired by Google. So this is 4 reasons behind the boom of artificial intelligence and deep learning. And this is the news of 2019. These 3 pioneers we just introduced in the middle, Geoffrey Hinton and Yang-Lan Kun, and another famous research, Yoshi Bengio. These 3 people won Turing Award in 2019. So Turing Award, we just mentioned Alan Turing in the beginning. So Turing Award is just kind of the Nobel Award in the computer science. So ACN, institute in United States, to create such a award. One way to honor Alan Turing. The other purpose is to choose the one who contribute to computer science in every year. So Turing Award was presented to these 3 pioneers in artificial intelligence in 2019. So we just introduced the deep learning and its concept. Now let us move to the variant of neural network. We will introduce you 3 famous neural network and its application. The first one is convolutional neural network, we call CNN. The CNN is trying to simulate human vision. So what is the key point of our human vision? What is the action we see the object? Discriminate what is this object. For example, you see this picture below. You probably know the left object is apple. How do you know this is apple? So we introduced another concept called features. We discriminate an object from its features, not the whole object. As you see, the apple is just maybe 1/3, not the whole object. So why we know this is apple just by one third of this object? Because we know the shape of apple. We know that we know its shape is like apple, and we know the color is like apple. So apple is the yellow and red, and we know the texture of the apple. So after the reflection of the candle, it seems very, very smooth. So that is apple. So we can discriminate object from shape, from color, from texture, from all the features. We don't need to see the whole object. So the feature is very important for human vision. And we have a traditional way to do the feature extraction. We call it matrix convolution. This picture is a simple example. This is the 6x6 image. We have the filter. Filter is a matrix. It's a 3x3 matrix. He can filter out the feature that the filter want to emphasize. As you see the filter, there are one in the diagonal, and the other side is -1. So this filter stands for a features, top left to right bottom. So this filter with doing the convolution with the image, and the result we call the feature map. So as you see that the biggest number in the feature map, top left, bottom left, and others is 0 or the negative. So why the top left and the bottom left with the large number? Because this original image has that kind of feature, similar to the filter in the top left and bottom left. As you see, they are 1, 1, 1 in diagonal, 1, 1, 1 in diagonal. So the result show that the top left and top right with the largest number. So this is matrix convolution. So this is a very, very traditional method and used in many fields. And some people, as we mentioned, he is a pioneer called Yann LeCun. He found such a matrix convolution can be implemented or can be presented as a neural network. We call the analyzed. How to implement as a neural network? We can flatten. We can transform this two-dimensional data to one-dimensional data.